Hi, good evening. Yes, in the previous section we referenced the instruction register, but we have yet to discuss exactly what that is. After manually performing the fetch cycle, we see that there's something left in the instruction register component. Let's discuss that now. You can see the value we put in RAM address 0 is now in the IR. The main purpose of the IR is twofold. First, as part of the fetch cycle, it receives the instruction. As you can see, the LEDs that hold this value are two different colors, and the description indicates that there is an instruction in blue and an operand in yellow. So, what's an operand? In this case, it's the address. In our SAP1 level example, we're using the first 4 bits for an optional address and the last 4 bits for the instruction. We only have a few instructions, so 4 bits is enough for that. Also, since the RAM only contains 16 bytes at address 0 through 15, 4 bits is enough for that too. All instructions do not need an operand, so when that's the case, the operand bits are just all zeros. You may notice that the IR has interpreted this value for us. You can see that it says LDA 14. So what exactly is LDA? LDA is going to be our first instruction in the addition program that we're working up to. You might have guessed that it stands for load A, and if you did, that's exactly what it stands for. Load the A register. Another important fact to know about the IR is that it has an I/O control line. This is, of course, an output where its value goes to the bus. However, for this component, it only outputs the first 4 bits, which is an address. This fact will prove useful because somehow we need to access the value in RAM that are not instructions but actual values. In fact, our final program, RAM address 14, will hold the value 28, which is the first number we'll be adding in our program, and address 15 will hold the value 14. Another equally important fact is that the instruction portion of the value is passed to the microcode component, which we'll be covering in a bit. Since we have completed the fetch cycle and the LDA command is ready to be executed, let's go ahead and manually go through the 2 remaining steps. Okay, so we need to get the address from the LDA instruction onto the bus and into the MAR. So the first thing we're going to do is enable IR's I/O, and the first 4 bits are going to go to the bus. So instruction registers I/O. Okay, so we have transferred the first 4 bits to the bus. So we're going to enable MAR's MI, and that's going to take those 4 bits from the bus and set the RAM address. And then, of course, we need on all inputs we need a clock pulse. Okay, that value has been brought in. We see the value retrieved, which that should be 28. Okay, so now we need to put the value of RAM address 14 into register A. So we're going to disable all the control lines, of course, except for halt. Okay, we got those reset. Then we're going to enable RAM's RO. So that value is going to go to the bus. And then we're going to enable register A's AI to take an input, and that's going to take the value from the bus. And then, of course, lastly, we need a clock pulse. So basically, we have transferred the LDA's operand, which is the value of 14. I'm sorry, it's stored in address 14, and we took the value of 28, and we transferred 28 into the register A. And of course, we already talked about the ALU. It's already started basically half our addition because the exact time that register A has a value, the ALU is going to operate on that, and right now it's operating on addition. So you can see when we almost have the full picture here. So basically, you have congratulations, you've executed your first full instruction on the CPU, and that's pretty much how it goes. And then we're going to later on define other instructions and then have a fetch cycle, execute that, and then we'll finally work up to the CPU automating the things we did earlier on our addition program. In our next video, we're going to start talking about the time steps. So, this was basically time 0 was fetch cycle, T1 was the fetch cycle, and then we did two operations. We did uh, getting the value of RAM into the bus, and then getting the bus value into A. And so we basically used 3 time steps to execute that. Now, some instructions have utilize T4, but not all instructions require that. So this is just a brief introduction to the instruction decoder, which I believe we'll be discussing next. Oh, one more thing. Before we discuss the instruction decoder, or ID, let's introduce a shortcut notation for documenting the steps to make our work easier. Just a note on this diagram. So, of course, you pulse the clock after each numbered step, not necessarily on setup. So ensure that the control lines that you see for the step that have an X are active. All other control lines need to be inactive. So if you've checked one from a previous step, you can uncheck that. Like I mentioned earlier, all instructions don't necessarily require step 4. So some do, some don't. In this case, it's basically a no operation. So we'll be seeing more of these charts later on, but you probably have a good idea of what we're talking about here. And it's just a quicker way to show you what needs to be done. All right, thanks. See you soon. Have a good evening.